In this video I'll show you how to quickly and easily create a camera fly around, which since the first Matrix movie came out is also known as a bullet time effect. So the issue here is this. Say you have a scene with several different physics simulations and particle systems and whatnot, like this one from the last tutorial. Check it out here on the channel. You bake the smoke sim and the particles and everything looks cool, but now you think, hey, this is a cool looking frame. Wouldn't it be nice to fly the camera around all of this, frozen in time, just the way it is right here, with all the baked info already available, no extra time to waste? You will quickly realize that this is quite difficult to do. Yes, you could go into the sim settings, maybe find a way to stop the particles by keyframing the settings in the particle systems. Somehow also stop the smoke flow from emitting and the smoke domain from dissolving, and so on. But this is definitely a pain in the butt and maybe even impossible in some cases, like the particle age that drives the material node tree is based on the timeline frame number. So many settings of every type of sim needs to be meticulously configured and keyframed and time remapped and then rebaked. I can't be bothered. What a headache. For something that you can easily do right here in real time in the viewport, right? I also started an interesting discussion about this in the Blender group on Facebook, which confirmed that there is no easy way to do this out of the box. Another idea I had, and someone on Facebook also suggested the same thing, was to actually replicate what they did for the Matrix movie. Place a whole bunch, like 100 cameras, in a circle around the subject and then select each camera, render, save image, select next camera, render, save image, and so on and so forth. Although this is definitely a solution to this problem, because you simply render the same simulation frame but from different camera angles, I didn't want to do this manually. And being a software engineer after all, came to the conclusion that I will need some sort of script to do this work for me. Now, I have never coded anything in Python, the programming language used inside of Blender, or done any meaningful scripting in Blender for that matter, but I was still able to throw this together in just a few minutes, thanks to the API reference here, and a few web searches of course. And here it is. I will try to explain what I did, and you will quickly see that this is actually super easy. So before coding anything, I do what I would do for the camera rotation anyway. I will add an empty sphere, maybe scale it up a little so we can see it better, and then parent the camera to the sphere like this. So now when I take the sphere and rotate it, I'm rotating the camera around my scene. Okay, and I also name this empty cam rot. Okay, now let's change the rotation of the empty using a Python script. So I'm gonna go into the text editor, create a new script. Let's call it bullettime.py for Python. Now the first thing we have to do is import BPY, which is the Blender Python module. We will need this to access everything in Blender and essentially remote control it. So let's see what we can do here. How do we get access to this empty here so we can rotate it? We can switch over here to Data API, and that gives us the tree of everything in Blender. So every object is in here with all the settings, and you can read stuff, you can write it, you can change it. So inside of this here, we can see we have objects, and then there's our cam rot object here, which is this empty. And then this empty has a rotation somewhere. Now you can find it in here, or you can do something even better. Let's try something out here. Let's print out the information that we want. So with bpy dot, you access everything in Blender. bpy is basically Blender. blender.data, which is this data API, this tree here. So everything in here is now in data. And with this dot notation, you can access, for example, the objects.objects. The objects is an array. So think of it as a list of all the objects in Blender. We can access them with a square bracket and then using the name, so camrod. And how do we get the rotation now? An easy way to do this is I have the empty here selected. I'm gonna right click here on the rotation of the empty and say copy data path and then paste that in here. So this setting here, the rotation, is called rotation_Euler. Cool, let's see what that looks like. Now this print is going to print out whatever is in this value here. So it's going to print out this rotation, which should be 0, 0, 0. And where does it print it to? Well, under Windows, we have to toggle System Console because that's how it is. So we can see it here. Let me quickly rearrange my screen. Okay, so now we have Blender over here. And if I go in here, maybe even make this smaller. This is not that important now. Over here, we have the Run Script button. So if I run this script, it prints it out in the console window here. And we get Euler, which is a rotation, x0, y0, c0. Cool. What if I take the c value and rotate the empty so that the camera is looking at the scene from this angle now? I run the script again. Now we have a c rotation. Now we realize quickly that this here, 0.033, is not 19.2 degrees. And that is because this value here is in radians and not in degrees. Okay, so how do we get this? First of all, we only want the c value. So we can say .c, run script. Now we just get this c value. How can we convert this into degrees now? We're gonna need the math library, and we can say math.degrees and then give it this value in the braces here, run script, and now we have 19 degrees, same as here. Okay, but we don't want to read this value, we want to set it, so let's see if that works. Let's take this .c and set it to a new value. So math dot, oh no, hold on, like so, math dot radians, and we want to set it to, let's say, 90 degrees. And run script. What's happening? Oh, it turned the camera to be over here. So it turned the empty. Camera is parented to the empty, so it's looking at it this way now. Cool. 45 degrees, run script. Neato, it works. Cool, but now I don't want to do this manually. I need a loop to do it for me. Okay, so how do loops work in Python? We have to write for, let's call it frame, in range between 0 and 100. So we execute, let's do it like this, execute this line of code 100 times, basically. And the frame variable now is the between 0 and 100, or actually 0 to 99. Now let's see, print frame. Let's see if that works. And it's printing out all the frame numbers up to frame number 99. Okay, well, now we have to turn this into a full circle rotation. So basically what we want here is 360 divided by how many frames? I said 100. You know what? I'm gonna declare a variable here, call it frames is 100 frames. So I only have to change one number up there if I want to change the length of my rotation animation. So 360 divided by frames times frame, right? 360 divided by 100 and then times my counter here. And in order to make this all a floating point operation, I'm just going to say 360.0, and that should be the rotation. let me simply copy this in here quick, run script, and we get all the degrees, starting at 0 degrees here, then 3.6, 7.2, all the way up to 356.4. And then the next one would be 360, which is 0 again. So we're getting a perfectly looping animation. And I'm already also changing the Z rotation of my empty. But of course we can't see anything when I hit run script. And when the script is done, the camera is where it was. So what can we do now? We want to actually render this image out and then render the image for frame 1 and then render the image for frame 2 and so on and so forth. So we kind of have to remote control Blender now. Manually, we would just rotate the empty, then go to render image, then save the image, then rotate the empty again and so on. We're just going to do this in this loop here. So we can render an image out by calling bpy.ops, which is like an operation that we're executing inside of Blender. The render operation, like this. But we want to save it to a file. So first we have to set the bpy.context.scene.render.file path. By the way, all of this is accessible in here. So this would be that file path. And we set the file path to a string. Now I'm in Windows, so I'm just going to set it to C, I don't know, like tutorials, and then bullet time, and then something JPEG. Now a backslash always needs to be escaped because \t would actually be interpreted as a tab character now. So I have to escape the backslashes. Of course, this is just because Windows uses backslashes. Now I want the frame number in here so that I get 000.jpg for the first frame. We can do that with a placeholder, %03d. What does that mean? It means a D for a decimal, an integer number, which is going to be the frame number. We want 3 digits, so 000. We want 0 padding on the left, and this is the placeholder, and we fill this placeholder with our frame number. So frame 0 is going to be 000.jpg, then 001.jpg, and so on and so forth. So I'm setting the file path where the file should be saved. Okay, now when you hit F12, you know that the image isn't really saved. So this is basically like hitting F12. But we can write the image to this file by simply telling this render operator here to write still is true. And that's it. Quick recap. We want the animation to last 100 frames. If you want 150, all you have to do is change this here. We have a loop that loops between 0 and basically 99 here. Then we're setting the rotation, the Z rotation of our empty object, which takes the camera with it. 2 radians of 360 divided by frames times frame, so the degrees for a perfect rotation on a circle here. We're setting the file path to a file name and creating an image sequence here with nicely named JPEG files that we can then simply drag into our video editor as an image sequence. And for this placeholder here, we're using our frame from the loop. And we're telling Blender, and now render this and write the still image to this path. And that's all there is to it. So I can save the file, which is always very good, because once you hit this run script button now, it's going to run through and create 100 images. It's also going to block the UI here, so Blender is not usable while this is running. And I haven't found a way to stop it actually from running. Once it's running, you're gonna see that it's doing stuff in here in this console that you can open with this toggle system console like I showed before. And while this is running, it's pumping out images. Now, since we only have emissive materials here, I'm also going to check my settings before I hit the button. So I have 32 render samples here, which is good. Now I have to find the one frame in my simulation. So this is all baked, okay? There's a baked smoke simulation in here. All the particle systems are baked. Basically, I can pick a frame now that I would like my animation to go through. So I'm picking frame 101. The goal of this whole thing is that we're just rendering this frame 100 and then have the camera fly around this frame 100 without changing the timeline frame. That's the whole idea here. So we pick the frame we want, frame 100, and then we hit run script. And now you can see it's doing something. It's already created 000.jpg. And now it's rendering the second file, and it created 001.jpg. And it's doing this. If I want to try doing anything over here, you notice I get this cursor. Blender is basically dead now. And like I said, I don't even know how to stop this now, so I have to let it run through. And then the result will be my camera rotation, and I will have 100 JPEGs on the file system. Even if you have zero clue about coding, I think this is not that hard to understand what these few lines here are doing. We don't need to mess with any settings and keyframing, we don't need to rebake anything. All we are essentially doing is the same thing we would do manually. Pick a frame of the however complex animation and simulation we already have, and then render that frame from different angles into files. All we did here was a simple circle rotation, but of course we could do a bit more. Maybe let the camera follow a path. Here I make a curve and define the path for the camera, parent the camera to the curve following the path, make the camera track to the center of the scene, and then use this line of code to set the evaluation time of the path animation, instead of rotating the empty. To get this kind of animation. And here is the same camera move, but on a different frame of the simulation. We are always rendering a single simulation frame wherever we put the playhead on the timeline, which means everything is standing perfectly still here. But like I said before, that is exactly what I wanted, a camera fly around on a single frame of an already finished simulation. That's what this tutorial and the little script we wrote here can give you. Patreons can download the finished blend file for free from patreon.com/chrisp. If this tutorial was useful or at least inspiring, then a subscription is appreciated. Thanks for watching, Chris P out.